All right, so our lecture today is a review for quiz 4. So first, for graphing quadratic functions, we're asking that you include at least 5 points. So in this first one, we're given it an intercept form or factored form where we can easily get the x-intercepts to start. So if I set this part equal to 0 and I solve, I would get that x equals 0. So I have an x-intercept at 0, 0. If I take this second part right here, set it equal to 0 and solve, I get a second x-intercept at -4, 0. So then when I plot those points, I'm at the origin and at -4, 0 right here. So those are my two x-intercepts. My axis of symmetry, my line of symmetry, has to be right smack in the middle. So I can already see that it has to be right here at x equals -2. If I want to confirm that algebraically, I can do x equals, I can take the p and the q, so 0 plus -4, and divide by 2. So it confirms that -4 over 2 is -2. All right, then if I want to get my vertex, I know that the x-coordinate is along that line of symmetry of x equals -2, so I need to plug in to get the y. So y equals -2 times -2 times -2 plus 4. So -2 times -2 times +2 gets me 8. So my vertex ends up being at -2, 8. So right here. And I can see that out in front, there's a -2. So the negative tells me vertical flip. And the 2 tells me vertical stretch by a factor of 2. So from that vertex, normally over 1, down 1, if there's that vertical flip, but I double that and I go down 2. Next points would normally be over 2 and then down 4, but double to get 8. And it shows me that I'm in the right spot, so I am good to go. There is my quadratic function, my parabola. Okay, next one is in vertex form, so I can extract the vertex really fast. 1, -3. So right here. Again, my axis of symmetry is that vertical line that slices through. So right here at x equals 1. I can also see the 1/2 out in front, which means vertical shrink by a factor of 1/2. So building off of that vertex, over 1, normally up 1, but I do half of it. Back to my vertex. Over 2, normally up 4, but I have it to go up 2. Connect your dots. Okay, there is my function. Okay, last one here, it's in standard form. So if I want the vertex, I need to do x equals -b over 2a. So a -1 times a -6 over 2 times -1. So 6 over -2 is -3. Okay, plug in to get the y. Y equals -1 times -3 quantity squared minus 6 times -3 minus 9. So -1 times 9 is -9 plus 18 minus 9 gets me 0. So my vertex is at -3, 0. So right there. Okay, it's on the x-axis. And then here will be my line of symmetry. All right, from here I can see that there's a negative out in front, so that tells me that there's a vertical flip. So instead of going up, I'm going down. So from that vertex, over 1, down 1, back to the vertex, over 2 and down 4 on both sides. Connect your dots. There is your parabola. Okay, 5 points minimum. I will always take more. Okay, next up, can we simplify with our imaginary numbers? So remember that there is a cycle of I. So we know that I to the first power is just I squared is -1. I to the third power is -I. And I to the fourth power is 1. And then that cycle continues. So I like to build off the I to the fourth power being 1. So when I look at I to the 33rd power, when I think about what number close to 33 is divisible by 4, and that would be 32, right? I know that that means that 33, if I divide that by 4, it would go in 8 times, right? Because 8 times 4 is 32. So I'm going to think of this as I to the 32nd power times I to the first. Now 32 is a power of 4, right? It's 4 8 times. So I think of it as I to the fourth raised to the 8th power times I. Well, I to the fourth is 1, so it's like saying 1 to the 8th power, which is just 1. So really 1 times I gets me back to I. So again, I'm counting off a power of 4. So the closest number below that's divisible by 4. All right, I to the 39th. Okay, I to the 36 is what I would build off of, times I to the third. Now I to the 36 is I to the fourth raised to the 9th power. So I know that this will simplify to be 1. Times I to the third, which is -I, leaves me with -I fully simplified. I to the 102nd. Okay, well I know that I to the 100th, right, that would be a power here that's divisible by 4. Build off of it 2 more. Now I to the 100th is I to the 4th power raised to the 25th power. So this simplifies to 1. I squared is -1. So I end up with -1 overall. Okay, last one, I have -12 times I to the 64th power. Well, 64 is divisible by 4, right? This would be I to the 4th power raised to the 16th power. So this part right here really just simplifies to be just 1. So -12 times 1 is just -12. Next, I'm just checking to see that you know how to simplify roots when we have negatives underneath. Oh, we have one more of this variation first. So here, -10i, all raised to the 2nd power. So in this one, that 2 has to distribute. So -10 times -10 is 10, right? So -10 to the 2nd power, 100, and then times I to the 2nd power. Well, I to the 2nd power is -1, so 100 times -1 is -100. All right, so then moving to the next one. Here I have the square root of -6. So the way that we think about that is the square root of -1 times the square root of 6. And anytime I see the square root of -1, that's just I. So we write our answer as I root 6, just like that. Okay, the next one, square root of -144. Still visualizing it the same way. Even if I don't write that square root of -1 every time, I'm visualizing pulling out the I. 144 is just 12, so 12i. Okay, square root of negative 32. Again, I'm picturing square root of negative 1 times square root of 32. Right, I'm pulling out the I. And then 32, well, that's 16 times 2, so 4 root 2. And in structure, we write that as 4i root 2. All right, next up, a little review of factoring. Lots of variations of factoring. First rule of factoring, always, always, is to look for a GCF. So here I see that both of those terms are divisible by 16, leaving behind a 4x squared minus 1. I notice that this is still a difference of two squares pattern, so I can factor it down further. So I have the 16 that's already out, and then 2x minus 1 times 2x plus 1. So again, GCF first, look for another pattern afterwards, right? That's a perfect square, that's a perfect square. So it broke into that difference of two squares pattern. Okay, next one, there's 4 terms to it. There's no GCF. The only option I have is to use grouping. So I look at the first 2 terms and I look for a GCF. They're both divisible by x squared, leaving behind an x plus 2. Okay, and then over here for the second 2 terms, all I can pull out is a negative 1, leaving behind an x plus 2. I love it. These packages, they match. So I can rewrite it, regroup it as x squared minus 1 times x plus 2. But I always have to think, am I finished? I am not finished, because right here, that's still a difference of 2 squares. I can break that down further into x minus 1 times x plus 1 times x plus 2. Fully factored. All right, looking at C. Here I'm looking for a GCF, and I see, they are all divisible by x, and that leading coefficient is negative. I'm going to divide out a negative x. So leaving behind an x squared minus 13x minus 48. So now I'm recognizing that this is a basic quadratic trinomial. I'm looking for 2 numbers that multiply to a negative 48 that add to a negative 13. Okay, it's got to be 16 and 3, and a negative 16, positive 3. All right, that's my full factorization. Okay, next problems. I'm saying solve the quadratic equation. I'm not telling you which method to use. So you can pick your method. Simplify any radicals. Some of these may have imaginary solutions. So the first one here, I'm seeing that this is the portion that's being squared. So I want to isolate that portion, and I'm going to solve this one by taking the square root. So first I'll subtract 8. So 4/5 of x minus 3, quantity squared, equals a negative 20. Clear the fraction. Multiply each side by the reciprocal, which is 5/4. This clears to 1. So now I have x minus 3, quantity squared, is equal to, if I reduce that 20 and that 4, that goes to 5 and 1, and negative 5 times 5 is a negative 25. Okay, solve by taking the square root. X minus 3 equals plus or minus 5i. Add the 3 to the other side, and we have our solution. 3 plus or minus 5i. Okay, next one. Here, looking at it, thinking, how do I How do I solve for x? What are my methods? I can't solve by taking the square root here because I have a linear term. So my other options are to factor it, complete the square, or use quadratic formula. This one looks factorable to me. So when I think about what it has to be in the first two positions, a 3x and an x. Now that 20 has to be a 1 and 20, 2 and 10, or a 4 and 5. And one of them has to be negative. So if I tried the 20, right, if I put a 20 here, that's going to get me a 60, right? A 3x times 20 would be a 60x paired with a 1x of some sort. That's not going to get me that negative 11x in the middle. And even if I flipped it, put a 20 here and a 1 here, it's still not going to get me that negative 11x in the middle. So if I sort through my options, what if I put a 2 here and a 10 here? Again, not going to get me negative 11x. And same with the other option. So my last choice is really the 4 and the 5. So imagine, let me use pencil here. Let's say that I put the 5 here and the 4 here. The outer and the inner, right, would give me 12x and 5x. And even if one of those is negative, it's not going to get me the negative 11x that's in the middle right there. So that means it's really got to be switched. It's got to be switched. It's got to be the 4 here and the 5 here. Because here is 15x, here is 4x. And if this one is negative, then I will get my negative 11x in the middle. So that means I need a minus here and a plus here, and I have it fully factored. But it helps to kind of sort through your options to see which one makes sense. Okay, if I set this equal to 0 and I solve, I get that x is equal to negative 4 over 3. Set this one equal to 0 and solve, I would get that x equals 5. Two solutions right there. Okay, next one, I'd love to factor it, but I can't think of something that multiplies to negative 4 that adds to negative 12. So since that middle term is even, I'm going to complete the square. So I'm going to add 4 to both sides. X squared minus 12x equal to 4. I take that middle term, I split it in half, and I square it. That gets me 36. So x squared minus 12x plus 36 equals 4 plus 36. What I add to one side, I always add to the other to balance it. This is a perfect square trinomial. It factors into a binomial squared, x minus 6 as a quantity squared, all equal to 40. Now I solve by taking the square root. So x minus 6 equals plus or minus, square root of 40 is 2 root 10. Add the 6. And I'll get that x equals 6 plus or minus 2 root 10. Final answer. Okay, last one. Right, I can't solve by just simply taking the square root. There's a linear term. So let me add the 10 to the other side and stare at it for a second. All right, now that it's all set equal to 0, it's not going to factor. There's nothing that multiplies to 10 that adds to negative 3. I probably wouldn't complete the square because that middle term is odd. I would use quadratic formula here. So x equals negative b, so negative 1 times a negative 3, plus or minus square root b squared, so negative 3 squared, minus 4 times a, which is 1, and c, which is 10, all over 2a, 2 times 1. Okay, so as I clean that up, x equals 3 plus or minus 9 plus 40, or not plus 40, 9 minus 40, right? We point that out because I often tell you that's a place to make a mistake, and I almost made one. So here we go. 9 minus 40 all over 2. All right. So now I have x equals 3 plus or minus the square root of negative 31 all over 2. So here I'm going to get 3 plus or minus I root 31 all over 2. Nothing to simplify further because there's nothing that goes into all 3 of these terms. This is fully simplified. All right, let's flip it to the back. Okay, next we're graphing inequalities. So here, this first one, I want to think, what would the quadratic function look like? So right now, I'm seeing that it's in standard form, so I need to do negative b over 2a to get my vertex. So negative 6 all over 2 times negative 1. Negative 6 over negative 2 is 3. Plug in to get the y. Y equals negative 1 times 3 squared plus 6 times 3. So negative 9, right, negative 1 times 9, negative 9 plus 18 is 9. So my vertex is at 3, 9. Right there. Okay, I also know that it's going to open down. So over 1, down 1. Over 2, down 4. Right? You want more points, go over 3 and down 9. Now, since it's less than not equal to, it's going to be dotted. And when I'm looking to shade a specific region, I'm really looking for where is it directionally? Is it saying greater than or more than? Or greater than or less than, right? So here, if I go to the vertex, it's saying less than. So I know that I'm meant to do it below where the vertex is because it's less than, not greater than or more than. So it should be this region. But let's say I wanted to double check by picking a point in this region. Maybe I pick this point, 3, 0, and I plug it in. So when I plug that in, 3, 0 as my checkpoint. So y is 0, less than. Here I'm plugging in a negative and then 3 squared. So negative 9. And then here I'd have plus 18. So that would give me a positive 9 overall. I'll just get to a little faster. Negative 9 plus 18, positive 9. Is 0 less than 9? Yes, absolutely true. That confirms that this point right here is in my solution region, and that's where I'm shading. All right, next one. Here I'm given really the factored version, the intercept version, so I'm able to pretty quickly get to my x-intercepts. All right, so I have 4, 0, and 6, 0. I'm going to go ahead and plot those on my graph. And I know that my line of symmetry would be right in the middle. If I want to confirm that, I know that x equals p plus q over 2. 4 plus 6 over 2, 10 over 2 is 5. Plug back in to get the y value of the vertex. So here we have a negative 2 times 1 times negative 1. It's going to get me a 2 overall. So my vertex is at 5, 2. So right there. If I want a few more points, right, use that it's a vertical flip with a stretch factor of 2, vertical stretch of 2. So over 1, down 2, over 2, and down 8 puts me here and here. Now, since it is greater than or equal to, now it's going to be solid when I graph the quadratic. And then it's a matter of where I shade. So if I go to my vertex, the fact that it's greater than, more than, that means I'm shading above where my vertex is. And if I wanted to plug in a checkpoint, I would probably use the origin. So check with 0, 0. So is 0 greater than or equal to -2 times -4, right? That would be 8 times -6, which would be -48. Yes, absolutely, that's true. So I'm shading in the region that contains the origin, the region that is above where that vertex is. Okay, next skill is solving systems using algebra. So using substitution or elimination. Oops, let me slide that back to there. Okay. So here, if I want to use substitution, I need to get y all by itself. And I would do that for the line, that second equation. So I'm going to subtract 2x to get the y by itself. And once the y is by itself, I'm going to take that -2x plus 7 and plug it in for the y in the other equation, right? I'm going to plug in equivalent values. So now I have x squared plus 2x minus, in parentheses, -2x plus 7 equals 5. Okay, distribute that negative. So x squared plus 2x plus 2x minus 7 equals 5. Okay, I'm going to take away the 5. X squared plus 4x minus 12 equals 0. Okay, this is going to factor. So when I factor, I get x plus 6 times x minus 2 equals 0. And when I solve, I get x equals -6, x equals +2. So now I plug in, and I plug into the format that's easiest. So I would just plug right into this format for the line where y is already isolated. Okay, so if I plug in the first one, y equals -2 times -6 plus 7, right? 12 plus 7 is going to give me 19. So that solution will be -6, comma, 19. For the second one, y equals -2 times 2 plus 7. So -4 plus 7 is 3. So I'll have another solution at 2, 3. I can always plug back in to double check that it makes both of my equations true. Okay, this next one I want to use elimination. So I want opposites in my y. I want to get rid of the y. So I'm going to look at the y up top, -3y. Bottom is just y. So I'm going to multiply everything in that second equation by 3. Rewrite that first equation. Triple everything on the bottom. Add down to eliminate the y. So 5x squared plus 5x equals 100. Okay, take away the 100 from both sides and see if you can factor it. Okay, there's a GCF of 5. Divide that out. Okay, Okay, factor out what's left. So something that multiplies to a negative 20 that adds to 1. It's got to be x plus 5 and x minus 4. So I have two solutions, right? X equals negative 5, x equals 4, and then I have to plug in to get the y value that pairs with each one. So if I plug into this equation right here, negative 5 squared plus 2 times negative 5 plus y equals 0. So 25 minus 10 is 15 plus y equals 0. Take away the 15. So y is negative 15. So that solution would be negative 5 comma negative 15. And if I do the same thing for the second one, here I have 4 squared plus 2 times 4 plus y equals 0. So I have 16 plus 8, 24 plus y equals 0. Take away that 24, y equals negative 24. So my second solution would be 4 comma negative 24. So those would be the 2 points of intersection. Okay, next, can you complete the square to write a quadratic function in vertex form? Okay, let me pull that down. All right, so here I'm going to add the 3 to the other side first. So y plus 3 equals negative 4x plus 32x. Divide out that coefficient in front of the 4. Okay, leaves you with negative 4 times x squared minus 8x, and then I'm just leaving room to complete the square. So I take that negative 8, split it in half, and square it. So I have negative 4 squared, right? Quantity squared gets me 16. But I didn't just add 16 to the right-hand side. I have a negative 4 times 16. So that's negative 64. So I need to subtract 64 from the other side to keep things balanced. So now I have y minus 61 equals negative 4 times, if I write this factored, x minus 4 quantity squared, and then add that 61 to the other side. Okay, my equation would be negative 4, y equals negative 4 times x minus 4 quantity squared plus 61. Okay, next, can you write an equation for a parabola in vertex form when we are given a point that it passes through, right? That's xy, and the vertex, that's your hk. So remember your format, y equals a times x minus h quantity squared plus k. So if I plug in what I know, y is 15, I'm leaving a because that's what I need to solve for, times negative 7 minus a negative 5 quantity squared minus 9. When I subtract a negative, it goes positive. So now I have 15 equals, I have negative 2 as a quantity squared, so 4a, and then still minus 9. Add the 9 over, and divide by 4. So my a, my stretch factor, is 6. So now I rewrite it as g of x equals 6 times x minus the negative 5, reads as x plus 5, quantity squared, minus 9. So really, I just had to get the A. I had to know if there was any flip or stretch factor. Okay, next I have a system of quadratic inequalities. So I need to graph each of them. So the first one, left 1, down 4, with a stretch factor of 2. So over 1 up 2, over 2 up 8. Okay, it's going to be dotted. And I know that if I shaded, it would be above the vertex, right inside of the U, right here. Okay, that bottom one, left 1 up 2. But I have a flip, a vertical flip, and a horizontal shrink of 1/2. So over 1/2 and down 1. Okay, and then if I was going over 2, right, half of that is over 1 and down 4. So here and here. This is going to be solid because I see that it's equal to, and below the vertex puts me in this space right here. Okay, but are these points solutions to the system? So 0, 0, right? That actually would not fall in this shaded region, right? Because this curve is actually coming down. If I kind of tighten it, kind of like that, right? It's not going to include 0, 0, so no. Okay, -1, 2, right? That's where it's solid, right? So that is in my solution region. -2, -2, right here, this point, right? This part is dotted. So even though it looks like it's where they overlap, since that part is dotted, it's not in my solution region. Okay, and then -1, -4, again, this part is dotted, so that's not part of my solution region. All right, almost done. So solving a quadratic inequality. So first I'm going to take away the 24 from each side. And then factor it. Pull out a GCF. Okay, recognize that it's a basic quadratic trinomial, multiplies to -12, adds to -1. I can get 2 times x minus 4 times x plus 3, all less than 0. My critical points, when I solve for x, set equal to 0, solve for x, I get x is 4 and x is -3. If I visualize this as a quadratic, and I plot those critical points, so about here and here, here's my -3, here's my 4. I know that if I was graphing this as a function, it would have a stretch factor and it would open up. But now I'm interested in where is it less than 0? So right here is where my function would have a y value exactly 0. Here it would be more than 0, something positive, and here it would be less than 0, something negative. So I'm saying, where would my function be less than 0? So it would be right here to here. And since it's not equal to, I'd have hollow points right there. If you like to see it on the number line, you can graph it that way too. And then my solution should be anything from -3 to 4, parentheses. And I can always check by plugging something inside that spread back in to make sure I get a true statement. All right, last problem, word problem. I have a mouse that's hopping along a parabolic path. Okay, given by this function, y equals -0.2x squared plus 1.3x, where x is the mouse's horizontal distance, and y is the corresponding height. Right, both in feet. All right, so here there's no extra number attached, so we start at 0, 0, the origin, and if we visualize it, here is our upside down parabola. Okay, we want to know, can the mouse jump over a 3-foot high fence? So we're really interested in this vertex. What is the maximum height that this mouse can reach? We know that that max height needs to be more than 3. Okay, so if I find the x value of my vertex, x equals negative 1.3 over 2 times negative 0.2. So negative 1.3 over negative 0.4 gets me 3.25. So the horizontal distance traveled is 3.25 feet. Okay, and then we need to know what's the height that goes with it. So if I plug back into my function, I have a negative 0.2, plugging in that 3.25 quantity squared, plus 1.3 times 3.25. Okay, once I plug that in, I'm going to get a negative 2.1125 plus 4.225. Combines to be a positive 2.1125. So my vertex right here, right, traveled 3.25 feet to get to a maximum height of 2.1125. So poor mouse, to clear that 3-foot fence, needed to be more than 3 feet. But yet he's only 2.1125. So the mouse will hit the fence. Right? The maximum height that it reaches is only 2.1125 feet. Needed to be 3 feet to clear that fence. All right, have a good day.